Hello everyone, my name is Soumya Wadla. So today we'll be going on analysis of algorithm based on the project report of string matching. We'll be having a string matching idea. So on the project, so we'll be mainly focusing on the project definition, what is a problem that we are going to have here, and mainly focusing on the RT analysis and the tables calculated for the RT values, and also the implementation for the pseudocode and what is the conclusion and what is the pros and cons of the algorithms that we are using here. So well, first, the problem that we are taking in this one is that the main task is to locate all the patterns by using a string p. So I have going to take the string name p within a text string t. So I was calculating the length of the p is m and the length of the t is n, where n is always greater than or equal to m. So here I was taking n as a string and m will be the size of the text that I was taking. And the requirements I'll be mainly focusing on would be I'll be using two algorithms. One would be a KMP and also a naive string approach. So this would be like two implementations that we are mainly focusing on, and this will be my algorithm that I will be using here. So this is the pseudocode that I will be using. So I'll just briefly explain about the implementation that I've been doing here. So based on coming to the pseudocode that I have been taken here, so here by using the for the naive string matching, I will be using a naive string function where t and p will be the text and the pattern that we'll be using, and n and m will be the size and the length of the text for pattern. So and then we are once the function is given, once the inputs are given here, and then we'll be entering into our outer loop. So I have defined our outer loop here. So once outer loop will be ranging from n minus m. So n minus m would be length of the text to length size of the pattern, plus size of the pattern will be +1. So here in the name matter, so will be, suppose if we are entering into a b c d and then the pattern will be abc. So each text and the pattern should be matched. Until then the naive pattern will be repeating. So if the pattern and the text is not matching, then that will be directly taken to the first step, which is into the j loop. So from j equal to 0. So j equal to 0 is something they always it again goes back to the input, and then again it will be executing through, again it will be checking each and every string. So this is the running time for the naive n minus m plus 1, and this is the pseudocode for the KMP. Same thing that I has mentioned, and the running time would be here O n plus m. And the RT analysis, so I have taken here like 10,000 to 1 lakh values that I will be calculating here, empirical RT and the ratio and the theoretical complexity. So I have taken n from 1 to 10, and n would be 10 power 8, and here I have also calculated the predicted RT value. And so these are the values that I have been mainly focusing on here. So I have been calculated for both KMP and also a naive pattern. So this is the algorithms that we will be predicting and empirical. So empirical versus RB. So here is a see, I have taken till 0 to 10,000. So 10,000 it is showing a predicted value will be like increasing till 5, and it is also like slightly down, slightly up empirical. So here it is a straight line for the empirical, and then compared to algorithm 2. So this is the main advantage of the KMP algorithm. So predicted and empirical will be both will be like in the upper value. So for this program I will be using a Python. So we'll be just going through the Python program once. Okay, so the implementation that I have been gone through here for the naive algorithm. So this is the source code that I have been implemented here for my example K and text and the pattern that I have taken is a T and P. So once we'll be opening into so the program that I have been I'll be executing here ideally shell using a 3.11.3 version. So here I'm just copy pasting because I have written this code already. So here taking same inputs and then entering into the outer loop, and then entering into the while loop inside. If it's not matching, then it will be directly entering into the break. So directly will be running the program. Okay, so this file is not saved, so I'll just go to save, and I have just saved this file as s1. Okay, so I have saved, and so here it is the output. So this is the output that we are getting from the naive string pattern, and we'll be checking also with the KMP if my code is correct or not, and we'll be executing whether if it's um, correct or not. I'm just directly going through checking because I have already executed many times. So that's the reason I was just copy pasting here and doing by myself. So we'll be just checking whether if it's running or not for KMP algorithm as well. So run module, run module and save. So this will, oh yeah, so say in the same file it is also saved. Just the difference between the KMP and naive is that it detects naive takes like a lot of time. Like if the text and the pattern is not matching, it again comes for the first string. It always comes to the first string, and then it always starts to the counting again. So that would be the worst case in the naive algorithm. So once coming to the KMP, the best case for the KMP would be like it always like best case would be like if the string if the pattern and the text is not matching, then we can get the matching string matching will be very easy using the KMP file. So this is the conclusion that we can go through. So based on this experiment or based on this explanation, that we can see like a naive string matching is like much time taking than compared to the KMP. So KMP for larger input sizes due to this exponential time complexity. So time complexity is main reason for naive. That's why we are using for KMP. So we can also expect the theoretical complexity estimates to be like accurate values in both a naive and a KMP. So this is the video all about, and thank you.